this real quick. All right, so how do you do that problem? So there's a couple of ways you can approach this if you like, and I'll show you what I mean by that. So on this one right here, you have a choice. All right, I'm going to use my red pen so you can see the difference here. I can find a common denominator of this as it is, okay, understanding that this is over 1, okay?
Okay.
So you can do it like that, and I think for some of you that might be easier, but here's the deal. All right, essentially what you're trying to do is you're trying to find a common denominator for all 3 of these, okay? And I think if you do it like this, is faster. All right, so basically I put this over 1 just to show you that my common denominator should be W. Are you with me? So I'm going to multiply, see, because this is W, right? So I'm going to multiply times W on top and bottom here. And I'm going to multiply times W on top and bottom here. Are you with me?
Got it.
So this is going to give me W squared plus 16 is equal to 10W. Now, the idea behind this is that all of this is technically divided by W. All of this technically would be divided by W. Like this would be over W, this would be over W. So, but listen, just like we've done before, okay? So this is one way to do it. And at that point, you can cross multiply, but that kind of gets complicated. Okay, so what I try to do instead is that once I realize what my common denominator would be for every single one of these, so let me rewrite this again. So again, you can kind of continue on here if you wanted to by cross multiplying. Or you can do it like this, which is the way that I did it in the notes, okay? Now that I figure out that my common denominator is W, what I'm going to do here is I'm going to multiply everything times W. Okay, so this is going to give me W squared. This is going to give me 16W. And this one's going to give me 10W. And again, W times W is W squared. W times 16 over W, the W's would cancel. And you have 10 times W. Are you with me?
Got it.
Okay. So at this point, I want to set this equal to 0. By subtracting 10W from each side. So it's going to give me this. Wait a minute. I'm sorry, Carter. I messed up, man. I guess I'm a little rusty from not seeing you guys every day. I was like, man, that's not going to give me the answer that I think I should get. But anyway, when I multiply this times W, I just get 16, not 16W. That's where I messed up. So this right here should be 10W then. So again, I will subtract 10W from each side. Mainly so I can get everything on one side instead equal to 0. So basically the new part to you guys is this part right here. Okay?
Yeah.
And then from that point, then I'm just going to factor and trying to solve. So I have, let's see, factors of 16 that add up to 10. They're both negative, so I have this. So the answer is W is equal to 8 and W is equal to 2.
Got it.
That makes sense. Do you have any other questions? I mean, these are, I'm probably going to post this video, and more than likely, either kids haven't really looked at it or they don't care. I don't know which one. I kind of know which ones don't care and which ones are
so like on number 10 on the back.
On the same
would it be, yes, would it be pretty much the same thing?
Yeah, let's just do number 10 real quick, all right? So we kind of understand. Okay. This is a little bit more difficult, but it's kind of the same concept, if you will. So this is number 10 on 8-9. So this is what you have. And correct me if I'm wrong here. All right, are you with me?
Got it.
Okay, now here's the deal. If I factor this, I get P minus 6, or plus 6, excuse me, P minus 2. Okay, so now look at it, okay? What I'm looking for is I'm trying to find a way for me to have what's called the lowest common denominator, okay? But they all have to have the same denominator. Are you with me?
Yep.
So, see, these two are the same, so I'm good. But this one has a P plus 6, okay? So in order for me to have what I need, what I'm going to have to do here is I'm going to have to multiply all of this times P plus 6, P minus 2. That's essentially my lowest common denominator. Are you with me?
Yep.
And so at that point, once I figure out my lowest common denominator, then I'm going to multiply. First, I'm going to multiply this right here times this, the first one. What would I have left if I multiply 1 over P minus 2 times this? What do you think I would have? You want me to actually write it down?
Be like P squared times.
Now here's the deal, right? So I'm glad that I have you here because you're kind of letting me know what you guys understand and what you don't understand. So if I were to multiply this, so I'm literally writing everything out right here.
Okay.
All right, so hang on. So this is basically, that's me distributing. Right, so I'm just expanding what this says. And this is equal to 5P minus 2 times P plus 6, P minus 2. All right, let me zoom in. Actually, I don't have to zoom in. It's just right here. All right, does that make sense so far? I'm just distributing. I haven't done anything crazy.
Okay. Yeah.
Now, what you need to understand is that when I have this right here is going to cancel. So I end up with this side, I end up with a P plus 6.
Will that P plus 6 eventually cancel?
No, hang on just a second. All right, so let's just go with me. I don't know if it will cancel or not, but let's go to the next one. And, you know, I didn't actually write it on here. I also have to multiply this by P plus 6, P minus 2. I kind of skipped that a little bit. So this term right here, you have to multiply it times this term, and times this term. Are you with me?
Got it.
All right, so now, and this is probably why you were confused about that. That's going to cancel, that's going to cancel. So I just end up with a minus 5.
Okay.
Okay. And on this one, the P's minus 2's cancel, and I end up with 5 times P plus 6. Right?
Okay, this is starting to make sense a little bit.
Right, yeah. That part's the most difficult. So that's why I'm actually been kind of like surprised that nobody was contacting me, because I was like, oh, this is not going to be good for you guys. But anyways, I want to add like terms here. On this one, I'm going to distribute. So I have 5P plus 30. And really, at that point, is this a 6? Oh, man. This is 6. I think I caught it here. I'm making tiny mistakes here, but this should be a 6. I just miswrote the problem.
So you're basically just taking what you factored out and applying it to each term in the equation and hoping it'll cancel?
Yeah. Yeah, essentially something's got to cancel. Like basically your whole goal is that by the time I multiply it with this, basically the denominators in one way or another were all canceled. Does that make sense?
Okay.
All the denominators are gone after that step. And if that doesn't happen, then you're doing something wrong.
Okay.
Okay, so this right here is going to be 6P plus 36. And at that point, I'm just going to solve. Okay, so subtract, I don't know how you want to do this, but I'm going to subtract 6P from each side. And then I want to subtract the 1. So this is going to give me a positive 35. So P is equal to negative 7. Okay.
Mm-hmm.
All right, let's do one more here.
So I'm like, what about number 12?
Yeah, let's look at number 12, right? Because number 12 has no solution, and there's a reason why. So the thing that we haven't talked about yet is that whatever answer I get here cannot make the denominator on the original equations equal to 0. And if it does, then it's not a solution, right? So for example, kind of sort of like what I did on at the beginning of this lesson, I said, you know, like figure out what these cannot be equal to. Like for example, I know that P cannot be equal to 2 or -6. Why? Because if I set these equal to 0, that's what I would get. You with me? So let's just look at number 11 real quick. And again, you might want to do that at the beginning so you don't have to wonder like, okay, what makes this undefined? All right, so number 12, you get 5r over r plus 1 is equal to 4 minus 5 over r plus 1, like that, right? Now, on this one, there's no trickery in the sense that this 4 is over 1, right? So if I want to find a common denominator for each one of these, I'm going to multiply everything times r plus 1. Are you with me?
Yep.
Okay, so before I go on, let's talk about what r cannot be equal to. Now, r, which is the denominator, right? The denominator, how do I figure out what r cannot be equal to? So r,
0.
This part right here, the denominator, cannot be equal to 0. Okay? And if I solve for r, I get that r cannot be equal to -1. So if by the time I do my solution, or I find my solution, I find that the solution is r is equal to -1, then that means that that solution is not valid. Right? So I'm going to multiply this times the lowest common denominator, which in this case is r plus 1. Okay? So now I'm going to write it out just like I did before, just to make sure that we understand. Remember, when you do that, when you multiply like this, you are multiplying each one of these terms
by r plus 1.
Right. And remember, the whole goal of doing this is that your denominators, all of your denominators should be canceling out. So this cancels, this one, it's just 1, so it's fine. This one cancels, so I end up with 5r is equal to 4r plus 4 minus 5. So that's going to give us 5r is equal to 4r minus 1. And then I'm just going to solve for r, right? Now notice that at this point, I'm going to subtract 4r. And then I get r is equal to -1. But remember, I said just earlier, that this cannot be equal to.
Yeah.
So therefore, you have no solution.
No solution.
Now, there could be a chance that you have several solutions. Oh, thank you. You have several solutions, okay? And only one is not defined. Does that make sense? Kind of like on the last one, we had 2 answers, right?
Okay.
And one of those answers could have been fine, and the other one could have been extraneous. You with me?
So, I mean, if it, like you said, if it has 2 answers and one of them works out and one of them doesn't.
Yeah, it's fine.
So it's fine? Okay.
Yeah, it's fine. That may happen.
You would just mark the bad one out then.
Correct. Yeah, this one's only no solution because the only answer that I got was the only one that I couldn't have. Does that make sense?
Okay. Got it.
So do you want to do one more, or are you good? It's fine if you
yeah, we'll do one more. That sounds good.
Okay. Let's see if one looks worse than the other. Let's look at number 14. And then after that, if you want to, we can look at a few problems and you can kind of tell me what you think the lowest common denominator is going to be, okay? So this is problem 14. My wife is tired of hearing me talking about math all day. Sorry, wife. All right, so, I mean, my dogs are asleep. They just went straight to sleep. They know your pain. Well, yeah, I just put them outside, but they'll worry asleep. All right, so this right here on the bottom, McKay, I'm actually going to go ahead and factor it. So on the bottom of 14, you have a common factor of y. So when you do that, you have it like that. So the essential part about this is that you definitely need to factor every denominator because it's going to be a lot easier to see what the lowest common denominator is going to be. Okay, so if I were trying to look for my common factor between the two, what would be my common factor?
Y or -1.
Oh, hang on, right? When I talk about common factor, like, forget about this. If I was just subtracting these two right here to my left, right? Why would I have to multiply the left side?
The left side.
Look at this denominator, just the bottom part. What am I missing here?
Oh, the y squared. So you'd have to multiply the other side times y.
Right. So I would have to multiply top and bottom here by y, right? So my common denominator would be y minus 1. Okay. So what I'm going to do here is I'm going to multiply these times the y minus 1. Now, it happens to be this is also y minus 1. So if I were to try to find a common denominator, I would just multiply this times y also. Does that make sense? So this is what allows me to have this. Now, remember, and let me see if we understand one another, right? If I multiply this times this, the y's minus 1 are going to cancel, and I end up with y times y plus 6. Agreed?
Yeah.
Okay.
Because that's all that's left over.
Right. And on this one, if I multiply this right here times this, the y and y minus 1 would cancel out completely. Now we just end up with
y minus 4.
Like that. Now notice that I wrote that in parentheses, and that's important, all right? If people are going to miss that problem, is right here, because they forget that the minus applies to the whole thing, not just the y. All right, and then finally this one, if I have y minus 1 times this, I would end up with y times 1, which is y. You with me?
Yep.
Okay. So now, sorry, letting the dogs in. All right, so now that I have this, and I'm just free to solve. All right, so I'm gonna distribute here. So I have y squared plus 6y minus y plus 4 is equal to y. So notice that I distributed that negative among those two.
Okay.
And I'm gonna add like terms here. Now remember, anytime you have a square function, you want to set it equal to 0.
Equal to 0.
So what should I do?
Subtract the y over.
Correct. And I'm going to have a 4y, right? If I subtract y from each side, now we get negative, excuse me, I have positive 4y plus 4 is equal to 0. And then I'm going to go ahead and solve by factoring. So in this case, I have a single answer. I have the same answer twice, but I mean, it's one answer. Now, remember, if I were to see what y cannot be equal to, what I would do is I would take my common denominator, which is what I have here, and I would set that equal to 0. So if you want to do this at the beginning to figure out like if this is going to work out or not, this one's already factored, which is nice. So y couldn't be equal to 0, and y cannot be equal to 1. Are you with me?
Got it.
But see, the answer that I got is not this, so I'm good. Does that make sense?
Got it. So like on 13, you would have to factor out c squared minus 4c.
Yeah, you would. On that one, it's a little interesting because you have to factor all of them, right? So I mean, I wasn't gonna do that one, but let's just go ahead and do it. 13, because 13. Okay, let's just look at it. You'll know what I'm talking about. So I have 2 over c squared minus 4c is equal to 1 over 3c plus 1 over 3. Okay, so there's the problem, right? So I'm going to factor out like you said. So let me just rewrite it real fast because this could be a little bit more complicated. Okay. So this was going to be a little bit more complicated because all of these three denominators are actually slightly different. All right. Where in the previous problems, you had two denominators that were basically the same and one that was different. Okay. So let's just focus on this side right here. What would I have to multiply this to make it like this?
C.
Right. So C. So I know right now, so far, I should have a 3C as my common denominator so far, right? And that will get rid of these denominators for sure, but it's definitely not going to get rid of this denominator over here. Mm-hmm. This denominator is still going to be that. Are you with me? So now go with me, all right? Because you need to understand this. Now, this one right here, if I'm trying to find a common denominator with this, with the 3C particularly, right? I already have the C. I don't need that, right? But I don't have a C minus 4 in any of these. You see what I'm saying? So if I were trying to find the common denominator among all of these, I need to multiply this right here by a 3 and also by a C minus 4.
Yep.
Are you with me?
Mm-hmm.
So my common denominator, and again, this is the hardest common denominator on the whole homework, would be that. Or my lowest common denominator would be that. Are you with me?
Mm-hmm. Yep.
But normally I have to do one at a time, right? I have a 3C here. Like basically if I were looking for the common denominator here, I would have to multiply this by 3 and this by C minus 4. So that would give me a common denominator of 3C, C minus 4.
Got it.
Okay. And then again, I feel, or I think I should say, not feel, feeling, who cares? All right. I think for a lot of you guys, this is going to be the most difficult step is this, finding that. Okay. Which is only, I think it's only the second half of the homework.
Yeah. Just like mainly the back page.
Yeah, because, yeah. Okay. I may do one more here after that because I'm going to have all sorts of people lost here. All right. So now I'm going to multiply this right here times this. All right. So if I multiply this times this, notice that this would cancel and I would end up just with the 3, right? So I would have a 3 times 2 here. This one right here, I would have a 1 times C minus 4 because that's all I would have left over. Again, if I multiply this times this. And then finally, if I multiply this times this, the 3's would cancel and I would end up with C minus 4. Okay. So this is 6. This is C minus 4. This is C squared minus 4C. So this is kind of a mess. I have to add like terms here. Let's see, these are like terms. So that's going to be negative 3C. And then we have a minus 4 so far. Right. And then again, I have to set this equal to 0. And then I solve for that. So basically, once you get to that part, that should be the easy part if you guys know how to.
Oh, yeah.
Some of you guys do. Some of you guys never did. Let's see. Factors of 10 added to 3, so 5 and 2. So if I set each factor equal to 0, and I know I'm writing a lot, but again, I'm trying not to leave any steps undone here. Now, as a side note, right? I know that my answer cannot be 0 or 4 because if I set this equal to, and again, you don't have to write this. If I were to set this equal to 0, then c cannot be equal to 0, c cannot be equal to 4, but I'm good because those answers are not those. Are you with me?
Got it.
So this, what I do here, this actually basically keeps me my domain.
Okay, that makes sense now.
Yeah, like if I were asked to write the domain of basically this equation, then I would have to say that like everything is fine except for z cannot be equal to 0 or 4. All right, let me do one of the perhaps easier ones. But it's the same concept, just slightly different. All right, so let's look. I'm just going to do number 7, and we'll just, after that, then I'm done.
All right.
Okay, so number 7 has this. So that's what I got. And then, so essentially I'm trying to look for a common, so let's focus on the common denominator first. All right, so, and again, if you really wanted to, and don't write this down if you don't want to, if I were just finding the common denominator here, right, I would have to multiply this by 3. Are you with me?
Yep.
That would give me a 3v. So let me write this out here. So let's see. That would give me a 4 minus 3. So that would be 1 over 3v. So what's wrong with you, Birdie? Sorry, my dog is freaking out. Somebody's weeding in their yard, so she was losing her mind. So I have a 2v squared here. All right, so again, don't write this down because I'm just doing this like just to see how I'm finding the common denominator. So listen, at this point, on a simple problem like this, you could cross multiply and it'll be just fine. All right, it'll work out, doesn't matter.
Yeah.
But on this one right here, look at it, right? The 3 and the 2 have nothing in common. So again, do not write this down. I would have to multiply this by 2 and this by 3, and that's going to give me a 6v here and a 6v squared here. Are you with me?
Yep.
What would I have to multiply this to make this v into a v squared?
A 2v.
Right. Okay, so what I'm trying to tell you is that this right here would give me 6v squared, and I'm doing way too much work here, but that's that's what I need to multiply these. You see what I'm saying?
Yeah.
And like I said, this one's simple enough that if you were right here, you could cross multiply just fine, and it'll work out.
Okay.
Okay, but anyway, since we're doing this the way that we've been doing it, so this doesn't really matter. But if you're gonna do it like that, then this is a little bit more difficult, so we'll write this one out. I'm essentially multiplying every single one of these things times 6v squared. Okay, now this one is going to make this into a 2, and this one's going to cancel completely, and that's going to give me a v. So this is 4 times 2v. This one right here, the v is going to cancel out completely, and that's going to leave me with minus 1 times 6v. And then finally, this last one, v squares cancel. That 2 makes this a 3. So this one's equal to 3v plus 2. And then you solve for v. This one is not even a quadratic, so we should be good on this. If I subtract 3v from each side, I would get this. So v is equal to negative 6. Oops, I'm off screen. That makes sense? Sometimes I feel like these are more difficult than the ones we just did, just because you can't. You can't really factor this out very well. It's harder to see what the lowest common denominator is going to be.
Yep.
Okay. All right. Do you have any other questions, Carter?
I think that's it. I think I can figure the rest out. So
okay.
I should be able to.
Okay, buddy. Well, if you need anything else, or anybody who might be listening to this, then just let me know.
All right. Thank you.
All right, man. We'll see you.
Bye.
Bye-bye.